Good morning, everyone. Welcome to SINB1's presentation from Human Practices on Science Communication and Public Engagement. My name is Umar Wadali, and I will be taking you guys through this presentation. So, first of all, why is the public such a key stakeholder? Well, obviously, the public is the one, when we talk about any new innovative technologies, the public is the one that benefits from said technology, and as well as they also bear all the risks and consequences, be them socioeconomic or cultural or otherwise. Generally, the public is the one who will be using the technology, but who will also bear whatever consequences that these technologies have on society and on the environment. A lot of times, research is funded by public funds, and as such, there is a need for some accountability and transparency into how those funds are used. Therefore, it is important to engage the public into knowing how we're using those like hard-earned tax dollars into actually doing research that benefits society. Public trust, obviously. And this is across the board, not just in synthetic biology, but in various other fields. How much the public actually trusts a technology has a big bearing on how well it is implemented and the desired effects that it actually has on society. Also, there are a bunch of non-scientific values that that usually are not accounted for when we actually do the research in academia, and these needs to be integrated when rolling out a new technology. So those can include kind of philosophical, moral, ethical values that do have a strong bearing on how technologies should be used. And we, as Canadians, who live in a pluralistic democracy, as in it is a democracy where there are different people with different views, and it is and all those views and perspectives need to be integrated into how we do science and how we conduct ourselves in society. And lastly, for the most part, like science is meant to serve the good of society, and in order to do so, making sure the public is aware and involved in that process is important into making sure that it actually does serve that purpose. So we're just going to make a small delineation between public communication and scientific communication and public engagement for the purpose of this presentation. This is not to say that public engagement does not involve scientific communication or outreach. It actually probably, but for the purpose of this presentation, when we're talking about scientific communication or outreach, we're very much talking about scientists talking to the public about their research and their work. And that's very kind of unidirectional in the sense that it is very much providing information, as opposed to engagement, which for the purpose of this presentation is very much about this two-way communication, whereby information is shared from research and higher education, but the goal is very much for mutual benefit, for integrating like opinions from lay people, from the public, into our decision making, and both providing information but also listening and giving and having that interaction where there is a back and forth. Both scientific communication, outreach, and public engagement are important in various parts, but we're just going to make that the difference for this presentation so we can have more clarity moving forward. So for the purpose of this lecture, we're first going to talk about scientific communications and a few guidelines on some of the considerations you need to be aware of when making a communication plan or doing some outreach activity. And then secondly, we will talk about public engagement and specifically what are the different, what it is, the different modes of it, who is involved, how we engage people, and how we evaluate that. So first of all, what is synthetic biology? In the first presentation, you probably have been put through a process where you've discussed about the definition of what synthetic biology is, and this is something that is very important here as well when you're talking to the public. So for us scientists and it is very much, we talk about synthetic biology in terms of maybe the concepts that are involved. So the standardization of biological parts, biobricks, modularizing complex systems into things that can be orthogonally moved around into different systems, like promoters and RBSs and the like. Or we may talk about them in terms of the tools that we use. So whether we're using databases, libraries, we're doing certain regulatory circuits, CRISPR or otherwise. Obviously, or sometimes it is possible to talk about synthetic biology in terms of the applications that we ascribe to it. So be it the medical or therapeutic uses in terms of gene therapy, cell therapy, tissue engineering, agriculture, industrial, where you're with regards to energy, or the manufacture of useful raw materials or products in say rubber or polymer or fiber supply chains, or maybe in terms of environment, in terms of biosensors or waste like environmental remediation technologies. So as you can see, this is usually the definition that scientists ascribe to us. The definition we're going to be working with is that synthetic biology is the design and construction of new biological entities such as enzymes, genetic circuits, and cells, or the redesign of existing biological systems. And that's very much the definition that was adopted by the EU in an opinion piece on synthetic biology that we'll discuss further later. But that definition actually differs quite a lot from the definition that the public actually has of synthetic biology. So in a study done by the Hart Associates and Wilson Center in 2009-2011 from focus groups, they asked them what they associated with synthetic biology, and words came like artificial, fake, man-made. There's a big focus on cloning, GMOs, playing God, synthetic limbs, and things like that. So as you can see, the perspective of what synthetic biology is to the public is quite different from what scientists may perceive it to be, and it's important to be aware of that difference in perspective. So first of all, let's talk about the audience. So considering your audience and their background and their preconceived notions, for example, how we discuss about having what their definition of synthetic biology is, or what their ideas about what your technology is about, very much is important when you're to consider when you're developing a communication plan. So you have to really address their values, their interests, their worldviews. You shouldn't be going into a communication, some kind of outreach, without actually having at least asked yourself some of these questions, like what do they do? What kind of information do they have access to? What do they read? What do they listen to? Where do they go for this information? As you're aware, very often the perspective of a community is very much influenced by the people with which they interact with. They share the attitudes and beliefs of their peers in their social networks. So it is very much important to know where they get that information and what that information is, in order to understand what your audience background and preconceived notions is. It is also and there's an important point to make here, is it is important to make assumptions and not stereotypes. People within different communities have multiple feelings and perceptions about a topic, and even within a fairly homogeneous audience, you may find that there are differing opinions. So it is important that to research your audience and have an idea of what their preconceptions are, but you should not be stereotyping them as a result of this. And this is just a bit to talk about why scientists and experts in general find it a bit difficult to discuss to different audiences. As scientists, you are trained to communicate with your peers in the form of conference presentations, or when you're talking about your papers. So it is very much in a jargon-heavy kind of science, kind of method-focused approach, and that is maybe not something that is most suited to actually talking to the public. And scientists are not necessarily trained into talking to broader audiences. Also, scientists tend to live in a bubble. Maybe we are not fully aware of being living in academia, that you're not fully aware of some of the considerations that you may not have considered that people may have. A lot of times there is quite a rapid turnover in terms of when the science comes out and when you actually need to talk about it. In this time of COVID-19, we have like daily conversations about the new research coming out from the pandemic, and sometimes people are just too busy to customize their communications for specific audiences. And also, finally, and people do not try to do this on purpose. But sometimes there is the aspect that some scientists do try to impress their audiences, be it for because they're trying to have kind of a positive outlook out of it, or that they think in doing so that they're able to better communicate their science, but sometimes it doesn't actually serve that purpose. So one idea that is important to consider is the idea of framing. So framing is very much, it's a concept in communication where one piece of information can be presented in different ways depending on how you discuss it, as in what ideas do you associate with this in explaining a certain concept. For example, say you're engineering stem cells to produce insulin. If it is explained, it has been found in focus groups and workshops that if it is explained in terms of the medical applications, which is to treat diabetes, there tends to be more of a positive spin on that new technology, as opposed to if you're talking about in terms of engineering stem cells and doing any kind of genetic manipulation, there's maybe more of a negative outlook on this. These are important considerations into how you actually go about and frame your ideas. As well as how you frame your ideas, it's important to understand how your audiences themselves have framed those ideas prior to your interaction with them. So there is generally two types of framing. You can have kind of top-down framing, which is generally from media outlets. This is very much from listening to the news or any kind of generally kind of newspapers or anything that they read that is very much information provided to them. And then there's more bottom-up framing, which is something information coming up from people in their social groups, from social media, from blogs. These tend to be a bit less filtered and kind of verified than kind of more formal journalism. But you need to be. It is worthwhile considering, what kind of how the technology has been framed by them, by the media available to them, and some of the caveats. And that's not to portray any kind of media or social media in any way, but these are things that obviously sensationalism is a key factor in these industries. So sometimes some risks or benefits might be exaggerated. So either way, that's not a good thing, because you do not want some kind of treatment for cancer per se to be touted as the new cure for cancer, that is, or that it is kind of a panacea for everything. It is important to kind of manage the hype essentially about certain technologies, as well as it's important not to exaggerate the risk about something. The ability, for example, a lot of technologies regarding how there are their potential for being released into the environment, the risk is often made to be much bigger than it actually is. There's also an important idea about what timelines are. So the media timeline is very much fast-paced. It's a quick turnaround. As soon as a discovery is made, you will have it in the news, and people will start discussing about it. How science actually progresses is on a much slower timeline. So by the time something is developed, you need to develop the product, go through regulatory approval, then implement it, and then evaluate the technology before it actually reaches market and impacts people's lives. So in that time, there is actually quite a bit of this can be months to years, and there is actually quite a bit of time to discuss this technology and to engage the public in terms of how it best be used. And it's important in that sense to not give the impression that as soon as something is discovered, you are immediately bearing the risks or gaining the benefits. It's also that some media tend to downplay governmental oversight. Just because the technology has been invented does not mean it will obtain governmental approval or regulatory approval. There are entities, and we'll discuss about this in a future lecture as well, that do guide how and determine the risks and benefits and how technologies come to market. With regards to framing, it's important to define what synthetic biology is, but also what it is not. So there's a lot of communications that you will see, or outreach you will see, that make a clear difference between what synthetic biology is and genetic engineering, for example. Like synthetic biology sometimes is not discussed in the terms of, say, gain-of-function research, for example, so which means like and trying to enhance human capabilities into any way. Sometimes it's important to talk about your technology, so that because, say, your technology, say, uses CRISPR, and it is used in a very specific medical application, for engineering stem cells, or say for engineering the gut microbiome or something like that. Just because it's CRISPR, people shouldn't you should be clear that it is not, say, like engineering embryos or things like that. It is important in your definition and how you frame things to tell them delineate what your technology is and isn't, and also you need to consider kind of the desired reaction. So is the purpose of your outreach very much to get people to maybe be more on board with a certain technology, to be more comfortable with it, or is it maybe just to provide a start for debate? And that very much affects how you frame your technology, as well as consider how you're actually listing your application, your risks and benefits, how you're ordering them, and how you're emphasizing them. Very much, there are sometimes that people are very concerned about one particular application, risk or benefit of something, and if you start out with that, or you overemphasize that, they may not pay attention to other risk, benefits, and applications, and that may skew their opinion on something. So it's very much not about kind of diverting the public's opinion on any given point, but just making sure that you order and emphasize your points in a way that provides a fair assessment of all the risks and benefits, so they can make a more considered opinion of it. And that brings us on to content, to the balanced content. It is important, as much as generally people who will present the technology are in favor of it, that it is important to present a balanced content. So in terms of having both sides of the story, maybe say you're discussing the ethical considerations of a new plastic remediation system, or some kind of fossil fuel remediation system, a bacteria that will degrade harmful fossil fuels in say water systems. It is important to address not only your own opinion on it, but also any kind of opposing or minority opinions that people may have about the idea. Just presenting one side of the story gives the impression that you're biased and your information is less trustworthy. You also need to be prepared for different reactions. So you be able to respect those moral, ethical, and personal reasons for people disapproving with things. There may and it is, and we'll talk about this more later, more in terms of the deficit model, but the fact that people do not agree with you is not an indication that they do not understand the technology. Well-informed audiences can very much disapprove on other grounds, and it is a factor that it is a consideration that you need to understand, that lack of information is not the reason why people may disapprove of your technology. And also it's important, again, to not overhype or underhype the risk and applications. Do not very much in especially when and we'll talk about this more in the next slide, but be it at the research stage when you're trying to apply for funding or a publication, there is the temptation to exaggerate some of the application or the scope of the research. Obviously, scientists are trained not to do that, but there is always, and especially when the media kind of catches a hold of it, that some things are overemphasized. And again, as we discussed previously, talking about the amount of time there is between something being discovered or something being researched about and coming to market allows plenty of time for public deliberation. And this is just to talk a little bit about how the hype is quote unquote is actually usually generated. So it comes from both ends. It could come from the researchers, where there's pressure to publish about certain hot topics that maybe garner more attention in the public, or maybe garner more of the funding from different agencies, or there may be the pressure to translate the research or commercialize it that may lead people to overemphasize some of the benefits of it. There could institutional press releases, if different institutions have maybe different agendas or maybe different ideas of what kind of technology they want to push forward. And there may be in trying to portray that research that things may be hyped. Media practices, obviously, and public interest and expectations. There is in media, obviously, there is always the sensationalism does sell, and while there is a lot of reputable media that actually does balance this research quite well, it is prone to falling into kind of that high pipeline. Public interest. So say you are a new technology could very much upend the way that you work or your industry works, or say producing a new way of producing a certain product that would essentially make your industry that would compete with your current job, or say a medical application that could treat someone that is very dear to you. There would be public interest and expectations into that would make people more keen to have it work a certain way, and that leads to hype, which obviously as a communicator is important for us to manage, to make sure that things do not get blown out of proportion. And as well as marketing and scientific bandwagon. So that's very much in the idea of a new product coming to market, and you're emphasizing the benefits of it, but it is very much important to emphasize the benefits within the scope of what the application actually does and the extent to which that application is effective. So the examples and definitions you use are also important into how your message is actually received. Research from the Wilson Center found that when you start a conversation about a new technology, especially when you're dealing with novices or lay people, it's more useful to start with the why, the applications of the actual technology, before delving into the how and the what, which is very much the science and how you've come about to develop that technology. It's generally, as scientists, we have very much the inclination of starting with kind of the science, the methods, how we came about the research, and then talking about the applications. But in terms of when talking to lay people, it is useful in terms of how much information is actually passed on and the interest that you garner if you start with the application. But definitely still talk about the how and the what and the science. Also consider how the examples are perceived. So things to do with renewable energy, human health, environmental protection are usually perceived in a positive light, whereas things about releasing things in the environment, anything to do with food or how it affects or existing chemicals, anything that people use in their daily lives, maybe has more of a negative impact. So maybe when you're considering what example to give of your technology, it is important to consider how these examples are generally received. And for a good definition, again, we've talked extensively about definitions in the previous presentation, but it very much should be tailored to your agency and your institution. Say you're talking to a set of risk assessment agencies. You very much want to talk about the science and the delineations and what constitute a definable risk or not. But when you're talking to, say, an audience that deals more with maybe the human rights issues surrounding something, or maybe the ethical issues surrounding something, it may be more informative of them, of maybe drawing similarities and differences with other frames of reference, like is this like nanotechnology, is this like genetic engineering, and integrating that to definition and having that shape how they perceive or define the technology. And also it's very, very important that you can always be consistent in your use of a definition throughout the communication process. Changing back and forth between different definitions, it draws confusion and will make your communication plan less effective. The messenger, so very much having a trusted messenger, someone who's trustworthy, is important into how effectively an outreach or communication plan happens. So based on the 2013 survey by Hart Associates, they found that university scientists and researchers are actually among the people who actually garner the most amount of confidence from the public, and with that actually comes a fair deal of responsibility, but also it means that you can actually that university scientists and researchers actually fairly well perceived in terms of how accurate their information is, because they're considered experts on the content. If you're communicating to someone, and especially with specific cultural groups, people with similar cultural associations as them may be perceived as a more trustworthy messenger, and you need to be aware of that. As well as a lot of outreach programs are very much about trust building. So it is, and how you actually develop the trust of the people you're talking to is maintaining transparency, making sure that that people are aware whenever information may change, or what you're doing with the information and how you're processing it, listening and responding to feedback. The more people feel involved into the communication process or the outreach process, allows them to build a certain sense of trust with the messenger. Addressing the needs of society. They need that very much goes back around to making sure that your technology is serving a purpose that they will actually find beneficial, and that builds trust essentially. The environment, generally for most people, when you work to improve the environment, is a trustworthy thing. Communicating frequently and often. So I cannot kind of stop emphasizing on the importance of actually clear lines of communication between whoever your audience is and yourself, be that before, or providing lines of communication if they have questions after. If you're producing any kind of like public media, for example, like a podcast or some kind of information that will be publicly available, maybe like consult with them with your final work. Once you're done processing the information, make it available to them if they choose to, and that really builds trust between kind of the scientists and the public they're discussing to. And also getting input from audiences into how to select a messenger that they find trustworthy. Very much sometimes things are already decided and we just invite people to outreach programs, but especially in communities that maybe have maybe more skepticism regarding the work that you're doing, it is important to actually maybe discuss with them with what they would consider someone that they would be able to trust in discussing new technologies. So as a good messenger, you need to accurately, but also evenly portray advances in science. So that again goes back to balanced content. You need to be able to reduce false hope, so prevent hype, prevent unnecessary risk amplification. Very much do not overemphasize any kind of the risks and how imminent those risks are. Build a more realistic perception of synthetic biology. So this is very much the idea of having a more defined idea of how things actually will be laid out, as opposed to kind of hypotheticals, and provide obviously a balanced content of balanced public awareness of the field. Again, that's discussing minority opinions and any kind of opposing opinions that may be present in this pandemic. Like people like Dr. Anthony Fauci are very much examples of a good communicator, someone who portrays kind of the gray area in science and the uncertainties, as well as being able very clear as to what is found and not overhyping, underhyping certain risks. So with regards to language, as much as possible, use clear and simple language. Try to eliminate scientific jargons and use metaphors. They're a very useful tool in terms of explaining complex concepts, but you need to be careful not to oversimplify things, or at least provide caveats when you use a metaphor. Or so, for example, synthetic biology is often described as software in terms of like being able to copy paste things, or being able to engineer a biological system in a way to work in a modular way. But this may, for example, give the impression that you can program an organism at will and to make it do whatever you want. That's not the case. There are restrictions into what the technologies we have for, say, gene editing or regulatory systems in cells. What we can do as with the level of technology that we have at our disposal, and displaying as a software, which is something much more malleable that you can program in any way, may give false impressions of what the science can actually do. Avoid sensationalist examples or hooks as much as possible. We are very much often all guilty of that when we're trying to kind of draw crowds or draw people to certain discussions, but you need to be careful in your language not to include those. Always provide caveats to new technologies, so make people aware of the risks, of the uncertainties, what you have researched, what needs further research, and always get feedback from experts about risks and applications. So none of us are experts of everything, of every application, and talking to experts who very much understand kind of where the science is at and where the rest of their field is at helps kind of deciding what kind of language to use and what kind of content to actually include and how to portray that. Just a last few things about communication is that the organism that you discuss about also has some kind of preconceived notions, usually in the public. For example, E. coli is often associated with foodborne pathogens, even though the form of E. coli that we use in the lab is non-pathogenic for the most part. The people associated with a pathogen, and they are just more skeptical of it. But the same research, say, done in yeast, may be viewed more positively, because yeast is associated with bread, beer, and food. This is not to say that you need to do your research in yeast because it's viewed positively. That only means that when you're discussing your research and you said that you have done your test in E. coli, you need to discuss really how your organism has been modified to be safe, how it is being contained, why that research is necessary, any potential risk with the model systems or the organisms that you've used, and any kind of safety precautions that have been taken in order to make sure that that research is safe, or that any tool or product that you're making available to the public is safe to use. And finally, regulatory oversight, and we'll have a whole presentation on the regulatory aspects of things, but a question that will come up whenever you're discussing with the public is, how we're making sure that the technology is safe. What is the government doing? What are other agencies doing to make sure that whatever gets to the public is safe? And it's hard to say for synthetic biology because very much regulations and regulatory protocols are very much still being developed as the technology evolves. But it is important for you as a communicator to be aware of where the regulations currently sit and what are the biosafety and biosecurity considerations that are available. So just to give you a very broad idea, as you will see in the diagram, there's different levels of regulation. So you have very much the formal regulations, which are things to do with IP, intellectual property, the regulation of the government, product liability. Those are things that are written in stone and all people are liable for. You have kind of more semi-formal ones, drug codes of conduct, voluntary agreements. So a good parallel to be made here is, say, for nanotechnology. In 2004, nanotechnology was at what we call the frontier expectations, which is what the media considered to be what they expected the technologies to be regulated. And it is very much, there was no formal regulation for it because technology was still evolving, was still being developed, and there was no way of formally regulating it. Now, today, nanotechnology is much more something that sits within the boundaries of having formal rules and regulations from countries into how what goes to market, what is considered safe and not, as well as voluntary codes of conduct. Synthetic biology at the moment very much sits at that frontier expectation where there are certain codes of conduct into what needs to be done and what is considered safe in synthetic biology, but the formal regulations and what's integrated into businesses and is very much still in development. And it is important not to gloss over that there is very much still a work in progress, and that what the uncertainties are and how they will be addressed before something comes to market. So now we'll just touch briefly upon public engagement. So just to reiterate what we talked about earlier, public engagement is very much the sharing information between the research community or the higher education community and the public. It is meant to be a two-way process, with the goal of having mutual benefit, mutual trust and relationship building, and very much integrating people's opinions into decision making. You will find that very much the public engagement has changed over time. Previously, a lot of the attempts at, or a lot of efforts, very genuine efforts at public engagement use the deficit model. So the deficit model was a model that assumes that the differences in attitudes and beliefs between scientists and the public is due to a lack of knowledge from the public. That if people were informed about the nature of technology and its benefits, they would very much share the beliefs and attitudes of scientists. And it was very much one-way communication and an effort to change behaviors and beliefs. That has very much evolved since then into a model of engagement whereby you're not so much trying to convince, there's very much still the need to bridge a gap in terms of the information that you provide to people, so they're able to have a considered opinion. But it is about very much that two-way communication, as in you're not just trying to give them information and trying to sway their belief, is you're providing information so you can then discuss and listen to them in terms of what their opinions are, and integrate that into how you actually do your research and how you move forward with the technology. So when do you actually engage is actually important in how you set up your public engagement efforts. So you could engage the public before a study, so in defining what the research question will be, what the research design will be, what the methods you will be using, or in terms of the funding decision. So maybe one fairly effective way that public engagement has been used is in defining maybe what funding goals should be from different public and private funders, in terms what should be something research that should be funded, and public engagement can be integrated at that stage. You can also have public engagement during the research. So this is so as prototypes and parts of your research become developed, it is very much important, you could have public engagement efforts to get feedback on your research design or your research orientation, as well as product development. So what I mean by product development is very much you have the product already developed, you're trying to fine tune it to a particular user. So for example, say you developed some kind of biosensor that is able to do a color change whenever you're testing for heavy metals in remote locations, in water systems. Maybe a consideration that they may have is that they do not have maybe the cold storage that you may need for your to maintain the temperature needed for your biological system for your sensor to stay active. A lot of bacteria have very strict temperature ranges, so maybe you may spend some time into developing some kind of system built into your device that can control the temperature of your device, so it can be carried around everywhere in those remote locations. Or maybe you want to it's very much getting feedback at this point from people who use it in the field and how that impacts your research. Also, this can be public engagement after the research is done. So how the findings of your publications are used and perceived, it might be important. It is important to engage the public at this point as well as further product development. So refining what a product looks like. You can engage people at that point as well. So who do you engage is actually a very tough question to answer, because it depends on what the goal of your activity is. Engaging the public is a very broad term. It's not very much the idea that you can engage everyone, or the people you engage have to be representative of who you actually want to reach with that technology. So they can very much be a mixed group. They don't have to be a homogeneous group, but they should be specific. For example, if you're talking about something that you're introducing in a lake for bioremediation, maybe you want to engage farmers and fishermen and people who rely on the lake and associated groundwaters for drinking. See, that is very much still the public, but it is a very specific public, one that is directly affected by the goal and rationale of your activity, which is maybe to engage them on how to put forward that technology, or whether that technology should be developed in the first place. And you will have resources available in the additional resources about how you actually go about looking for a specific audience and public, but it's important that you're able to give a rationale as to why those people are already involved in your publication. How do you engage is a very important question. Is your goal to inform and inspire, to gain knowledge, to change attitude or perceptions? That kind of feeds a little bit into the deficit model, but there is a need sometimes to bridge knowledge before a discussion can be had, and that can be in the form of talks, kind of exhibitions, podcasts, social media, very much where you're delivering information. You can engage people through more consulting activities, where you're trying to essentially get the participants' views on the researcher thinking and their research questions. So these would take the form of public debates, focus groups, opinion polls. Generally, there are certain caveats into using those different methods. For example, when you use online polling, you tend to only or opinion polls, you tend to mostly get people that are interested in your technology, or maybe have some kind of stake in that technology, and that may skew the opinions that you get. But you can also have opinion polls whereby um, you have a more of a deliberative process before you actually poll people. So you have a discussion and you instruct people on something, and then you poll them after. So that could be also be a way of consulting people. And then you have more of, and there's also things like online forums. There was an effort called the SymbioSafe e-conference, where they had a conference online, trying to get a landscape of what the range of opinions on different biosecurity and biosafety considerations were. And I encourage you to actually look at the SymbioSafety conference if you want a good example of how to do such a kind of engagement effort. You have more kind of collaborative activities as well. So this is very much at the point where you're not just trying to get the participant views, but they're trying active participants into how your research design and your methods and your directions are actually structured and how they change over time. So in the more formal way, that can be in the form of like citizen juries. You can have kind of public consultations as well, where so the BBSRC and the EPSRC, which are the two research councils in the UK, actually did a series of workshops and interviews to kind of collaborate with people to kind of get an understanding of their perspective on different technologies, and kind of clearly articulate that and see how that can influence decision policy and decision making. That kind of falls as well a little bit into consulting, but yes, but collaborating is also they're kind of bleed into each other, but collaborating is very much the idea of them being active participants into it. And that feeds, so you could have kind of co-production of knowledge, kind of community presentations, participative research, kind of dialogue that actually affects how your research design actually goes forward. And that feeds into very much the idea that is becoming popular now of deliberative democracy, getting diverse citizens to learn, discuss, and consider an issue in depth on a field. And that can be actually quite an honors engagement, and can be quite difficult, but it is useful into how you could actually do engagement activities. And very much how you structure your engagement depends on what your goal is. So is your goal to do landscaping, which is basically to have an idea of the range of opinions on a particular topic, or maybe it is to start or facilitate debate. Maybe you want to have people discussing about something, there's consensus, maybe you want to come up with a consensus from a particular community as to what their overall their overall opinion is on something. So is there like something that they can all agree on, or certain aspects that they agree on this particular technology? And maybe you want to have public engagement activities to have a decision or a judgment. That's a bit more in the sense of citizen juries, for example, where you present them the facts and you want a decision out of them. And that really feeds into what the product of your engagement is. Is it a statement that about a certain aspect of biology? Is it polling data in terms of the number of people that are in favor or against certain things? Is it an ongoing process in communication and decision making? Is it essentially like was the point of the public engagement activity to continuously involve people at various stages, to just keep getting feedback? Is the feedback is the product that you're seeking, maybe? So very much knowing what you're hoping to get out of it and how it will look like guides how you actually structure your public engagement activity. And how do you evaluate it? What is considered something that is successful? Are you going to measure it in terms of the number of views or downloads that a particular um, product that you put out there has, or is it maybe more in a qualitative sense where you get comments and feedback from people, and the usefulness of those comments and feedback, and how is what you consider to be like a successful and non-successful or unsuccessful engagement. And finally, it's important to see how your public engagement actually feeds into the decision-making process. So how does it feed into, say, the code of conducts that you may devise for a particular field, or a particular funding guideline, or if it is at the stage of like policy, is it helping to formulate a new policy? Is it used in terms of the ideas for new policies? Is it in terms of how you're evaluating whether a policy is effective or not? Very much having an idea of where you want that engagement to impact decision making is important to have. And finally, just quickly talking about some of the challenges in public engagement. So no one has really, a surefire way of doing public engagement. It's different in different circumstances, different technologies, different moral considerations, different regulatory constraints, and very often different public engagement take different forms and are more effective, and different modes are more effective in different scenarios. But general challenges that we see in public engagement are identifying the relevant public. So this is one we talked about, who is your public, who is the people that are your key stakeholders, and are they representative of the people impacted by your technology. There's the idea of reconciling cultural and socioeconomic differences. People will have disagreements on things just based on their cultural background, or what their own kind of commitments in a socioeconomic term are, and you need to be sensitive to that, and being able to facilitate debate while being aware of that people will have differences and will have differences of opinion, and being able to integrate that into your feedback, into how you actually deal with that, with the information you get. Also, it's hard to actually foster civil debate sometimes, especially on more morally contentious topics. So especially things that deal with quote unquote synthetic biology playing God, there are morally contentious or religiously contentious issues, to what can be done or not, or can be changed with a human body, or with regards to how a certain technology is put out into the environment. There could be differences of opinions into the morality of who is affected by it, and what the level of risks that are acceptable for different groups, and there's questions of ethics and morality there. And finally, the legitimacy of your process. It is quite. You need to understand that when you're designing a project, it needs to be in a way, and that goes back to transparency and balanced views, and having a representative public, so that people looking at the results of your research and your public engagement activity accept that it is, or find it to be legitimate, that it is not disregarding, say, the opinions of certain people, or not considering them into the conclusions and the recommendations that it actually makes. Making your process legitimate, appear legitimate, is very much something that is people contend with, especially in public engagement circles. So this is just the list of references. I would very much point you especially towards the course Engineering Life in Bioethics and Public Policy from Johns Hopkins University, from Dr. Deborah Matthews. A lot of the slides today were based on her lectures, and I would encourage anyone to really kind of go into that. Also, the Guide for Communicating Synthetic Biology from the Woodrow Wilson Institute. Center for Scholars that was very informative into how the questions to actually ask yourself when creating an outreach program, as well as the University of Oxford's guides on how to engage people in public engagement. A couple of additional resources. It is a fact that very often scientists are not used to presenting and evaluating qualitative research as much. Quantitative research is much more kind of the ball game for a lot of people. So I would recommend this paper by Claire Anderson on how to best present and evaluate qualitative research, and comments and feedback from interviews, focus groups, and how to do that in a very systematic way, as well as the RRI tools, or responsible research and innovation tools, on public engagements, provide a lot of good guidelines into what the questions to ask yourself and how to structure your public engagement activities. And yeah, thank you for your attention. I hope this has kind of broadened some of your horizons on some of the considerations you need to have in mind when doing any kind of outreach or public engagement. Thank you.